After you have acquired your data, you will need to convert the data into an ABF type file. You can do that by using the Reifycs Analysis Base File Converter, which you can download from their website, and this will convert your raw files into an ABF type file. The method to do is quite simple. You will just need to select your file, drag it to the interface and drop it, and then press convert. It will then automatically save your new files in the designated location. I will now demonstrate how to do the conversion. You first have to open the converter, then you will select your samples, drag and drop, and then press convert. As you can see that now the software will produce an ABF file in the exact same location which your original files are located. Once the process is finished, you can close the application and proceed to the pre-processing phase. Now on to data pre-processing phase. Before I demonstrate how to use MS-DIAL, I will mention a number of advantages of this program. First of all, MS-DIAL is freely available. Users can download this program from this website. Secondly, it has an easy-to-use graphical user interface. Therefore, it is an alternative to other software such as XCMS, which you may know that you would require programming skills to use it. Fourth, it has unique features such as data-dependent acquisition, and it can predict MS1 precursors from MS2 spectra generated by data-independent acquisition. Further information you can find in their website. To download the MS-DIAL program, you can access this website. Then you click on MS-DIAL and the program, and we usually download the latest version. In this case, the latest version is version 2.9. The developer of MS-DIAL usually updates the MS-DIAL program if there are new changes, and this will be notified when you first open the MS-DIAL program that you currently have. When you open the MS-DIAL program, you will directly see this workspace interface. What you will need to do first is to go to File, either create a new project or open an existing project. In this case, we select the new project. A pop-up will appear, and the first thing that you will need to do is to select the project file path. This path is the location in which you have stored the ABF type files of the raw data which have been converted using the Reifycs Converter tool. Following that, you will need to select the ionization type, either soft ionization when you're analyzing ECI type data like LCMS, or hard ionization when you're analyzing EI type data like GCMS. Since we are working with LCMS data, we select the soft ionization. Next, we need to select the method type. There are 3 different options, and in order to know which of these 3 different options that you will need to select, you can hover your mouse over the text. We select the swath NS or conventional all-ions method and provide the location in this box. An example file can be seen in this notepad, where we have imputed the experiment, the MS type, and the minimum and maximum mass. Then you will need to select the data type of the MS1 or the MSMS. You can select either profile data or centroid data. For detailed explanation of these 2 different options, you can hover your mouse over the text. We select the centroid data. Next, we need to select the ion mode, either positive ion mode or negative ion mode, and we select the negative ion mode. As for targetomics, we select the metabolomics, not the lipidomics. You can add further metadata in these boxes. This metadata will be saved, and it is important if you would like to store and upload your results to MassBank. Now on to the next phase. You can select your files by clicking on Browse and selecting them. You can assign individual samples in different classes by selecting and changing the class ID. In this case, we put category 1 for tomato leaves and category 2 for tomato trichomes. You can select and deselect, include and not include samples into your analysis by clicking these checkboxes. On to the next phase. Now on to the analysis parameter settings. I will not go explain in detail how I optimize these settings, but I highly recommend you to check out the tutorial guide on the MS-DIAL website. What we usually do is that we have already an existing optimized parameter setting, and we just load it every time you would like to run an analysis by clicking on the load button, selecting the med file, and there you have it. So in the data collection, I don't often modify any of these settings. In peak detection, I usually change the smoothing level, the minimum peak width, and the peak height. As for the MS2 deconvolution, we have this in 1 for the keep isotopic ions until and keep the isotopic ions without MS2 deconvolution checked. In the identification tab, you need to insert the MSP library, which you can also obtain from the MS-DIAL website, and modify the retention time tolerance, accurate mass tolerance, and identification score cutoff. We select the use retention information for scoring as well as together with alignment. In the adduct, we don't change the settings, we just keep it as -H. As for the alignment, you can easily modify the result name and select the reference file. We also check the detect in all QCs. And finish. Once your data has been analyzed by MS-DIAL, you'll be directed back immediately to the workspace interface. On the top left corner, you can navigate through all the individual samples. By double-clicking on it, you'll be able to visualize the picked peaks in the peak spot viewer. MS-DIAL extracted mass and retention time features from individual samples based on MS1 and the MS-MS level. For GCMS or DMS-MS data analysis, the relationship between quantification ion and mass spectra is not straightforward. Therefore, MS-DIAL extracts mass and retention time feature from MS1 and MS2 based on several aspects described in the tutorial, and it convolutes all features based on their chromatographic appearance. As a unique feature, it predicts the precursor ion or quantification ion in case of GCMS with electron impact ionization. To navigate through these peaks, you can use the Peak Spot Navigator. As you can see, MS-DIAL has managed to pick 2,316 peaks, and among them, 148 peaks are classified as identified, whereas 870 peaks are classified as annotated. The difference between identified and annotated peaks is that identified peaks are based on MS-MS spectra similarity, accurate mass, and retention type. Different to that for the annotated peaks, which are not based on MS-MS spectra, but only accurate mass and retention time similarity. Now coming back to the peak spot viewer. In order to zoom in, you will only need to right-click and drag. Then you can zoom and select your peak of interest. And to zoom out, you just need to double-click. And there you have it. When you select a peak, you can use and see the MS1 spectral in this graph. whereas the EIC of focus spot can be seen on top. Further information can be seen on the top right corner. As you can see, MS-DIAL provides the RT, retention time, the mass, compound name which was predicted based on the library which you have inserted. On the bottom right corner, you'll be able to see the MS2 spectra information. When you click on the Show Centroid versus Reference Spectra, you can see the spectra of your sample mirrored to the reference spectra from the MSP library that you have used for the analysis. The second button shows the deconvoluted spectra versus the reference. If you're not sure about the compound annotated, you can select the third button, which is a compound search. You can see the list of the predicted compounds which have spectral similarity to the compound of your selection. Now on to the alignment navigator, which is located on the bottom left corner of the screen. Whenever you run a new parameter setting, a new alignment result will appear below the current alignment result. These results can be visualized in the alignment spot viewer. Navigating through this viewer is similar to what I've already previously mentioned using the peak spot navigator. MS-DIAL has extracted mass and retention time features from individual samples, and here we align these features across all measured samples of a dataset. Therefore, when you zoom in very close, you can see how the extracted features of all 6 samples are connected to one center point. The center value is the average mass of all measured masses and the average retention time of all measured retention times. Green spot is associated with the detected flag, showing whether all samples contain the spot. Red spot is associated with the interpolated flag, showing whether the software augmented originally missing values. Large retention time shifts during the measurement causes the feature group to fall in 2 or more clusters. The alignment has to be repeated with higher retention time tolerance. Information on the peak and spectra can be seen on the right side of the workspace interface, similarly to what I have demonstrated previously. Another feature of MS-DIAL is that we can compare between the different classes of samples which we have imputed in the beginning during data import. We can see by selecting the bar chart of aligned spots. Class 1 comprises of the leaf samples, whereas Class 2 are the trichomes. You can also see the EIC of the aligned spots. If you're somewhat unhappy with the current parameter settings, for instance due to too high threshold for the peak picking or too low percentage of similarity to the library spectra, you can always change and modify and optimize this setting by going to the data processing tab and select either all processing, identification, or the alignment phase. On the other hand, when you are happy with your result, you can export it by going to the Export tab and selecting the alignment result. Here you can impute the directory where you would like to store it, select which alignment result, and select the raw data matrix, either the height or the area, as well as the representative spectra. I remind you that we need it in MSP format for the MET family, and just click export. After your data has been exported, you can go to the designated location of where you have selected to store your information, and you will see 2 files. The first one is the spectral library in MSP format, and the second is the height information. And these 2 files you will definitely need for MET family. In conclusion, what does MS-DIAL provide? First of all, it automatically picks peaks of MS1 and MS2 mass features. Secondly, it does chromatographic deconvolution of MS1 and MS2 mass features. Thirdly, it creates an alignment of the mass features between samples. And lastly, it predicts precursor ion or determine quantifier ions. As an output, you will be able to obtain MS1 in height or area metrics as a text file, and also an MSP spectral library, and these 2 files you can directly use in MET family. We have provided you a walkthrough of how to convert your data and analyzing it in MS-DIAL. So next, you can tune in our second video, which is on Met Family. And for further question, you can contact us to this email address. Thank you for your attention.